In this video, we're going to take a look and do some guided exam question practice on the Leaving Cert Chemistry question from 2007 that came up on Redox. Now, it was half a question, so it was worth 25 marks. You've got about 10 minutes if you want to grab your timer and set it now. So it begins by saying the halogens are good oxidizing agents. So halogens, this is group 7 on our periodic table, and it tells us they're good oxidizing agents. All right, so I don't know how important that piece of information is going to be. Let's jump into the actual questions. How does the oxidation number of the oxidizing agent change during redox reaction? So first of all, you have to know what happens to the oxidizing agent during a redox reaction. So that's the first thing to think about, what happens to it. All right, so you'll know that the oxidizing agent itself is reduced. So now you've got to think of what happens to the oxidation number during to this thing during a redox reaction. So this is really asking you what is reduction in terms of oxidation number. So we're going to go ahead and we are going to write down what we think. What happens to the oxidation number of the oxidizing agent? Oxidizing, or is it the reducing agent? No, it's the oxidizing agent. Right, pause the video and write down what happens now. Okay, so obviously the oxidizing agent itself is reduced. Okay, and if you weren't sure, reduction is gain of electrons. So let's pick a thing that's going to gain electrons. So say, for example, chlorine. Chlorine is an atom, it's uncombined, it's an uncombined element, and it's going to gain electrons during the redox reaction to become Cl-1. Now, assign oxidation number to this, it's an ion, so we're going to have a -1 ion. So we know that this is reduction, gain of an electron, and what's happened to the oxidation number? It has gone down, it has decreased. So to clarify this in a sentence, what happens to the oxidizing agent during redox reaction? The oxidation number decreases. And that's it. That's really all you needed, was that word decreases, but you do need to be able to think your way through it. So that's why we went through the process and not trying to learn anything else, actually go through the process and work it out. Next bit. Assign oxidation numbers to each of the following equations to clearly show the halogen is the oxidizing agent in each case. So remember, what do we want to show? If it's the oxidizing agent, it is reduced. So we want to show the halogen, which is the Br2 or the Cl2, we want to show that they get reduced. All right. So I'm going to go to part 2. And what I want you to do is pause the video and write down the 2 equations, leave a space between them. Do that first. Okay, so what you should have done is this here. You should have written Br2 like this, Br2 plus 2Fe, 2 plus, give you 2Br minus plus 2Fe3 plus. That's the first one. I'm going to leave a gap to the next one. It's Cl2 plus SO3 2 minus plus H2O. React to give Cl minus plus SO4 2 minus plus H plus. All right, so the next thing we got to do is assign oxidation numbers. Pause the video and do that now for both equations. All right, good practice here. Something very important skill to be able to do. First of all, we have the 2 halogens, which are elements uncombined. So bromine is just an element, so it's uncombined, so it's an oxidation number of 0. And that means chlorine will also have an oxidation number of 0. They're both uncombined elements. In the next case, we have ions. So the rule for an ion is oxidation number is equal to the charge on the ion. So if you didn't get this right already, pause the video and do it now. Fe will be plus 2 because it's a plus 2 ion, and SO3 2 minus will be a minus. Oh no, sorry, it won't. It'll be -2 on the oxygen. So -6 altogether for the oxygens. They have to add up to -2 because they have to equal to the charge on the ion. So in this case, sulfur is plus 4. Again, if I'm going too quick for you here, you don't understand this, probably not a good idea to be watching this video. You need to go and watch how do we assign oxidation numbers in my video and that in the playlist. Okay, so -2 and plus 1. So I'm just going to fly through the rest of this and assume that you guys know how to do this, because you really shouldn't be doing this if you don't know how to. It's better to go and learn it first. -2, 8. +6, and then this is +1. Okay, so that is your oxidation numbers assigned. Okay, the next thing I want you to do is use arrows to show which thing is being oxidized and which thing is being reduced in each reaction. Let's start with the first one. Okay, so pause the video, use arrows to show oxidation and reduction. Okay, using the red arrow here, I'm showing that the BR goes from oxidation number of 0 to oxidation number of -1. To do that, it had to gain an electron, gained 1 electron, and if it gains, then that is reduction. Using a green arrow now, the Fe went from +2 to +3. That means it lost 1 electron, but that's one electron, that is oxidation. All right, you do the same for the second one. If you weren't able to do the first one after seeing me doing that, you should be able to do the second one. Okay, so red arrow again, I see the chlorine is going from Cl0 to -1, and that is a gain of 1 electron, gain 1 electron, and that is reduction. And then the other thing in this reaction is the sulfur is going from +4 to +6. And that is a gain of 2 electrons. Sorry, no, a loss, not a gain, a loss of 2 electrons, and that is oxidation. Now let's go back to the question again. Just to clarify, don't try and remember everything what they asked you to do. Let's go back and check. What does it say? It says to show clearly that the halogen is the oxidizing agent in each case. So we've seen in both cases that the halogen, the bromine or the chlorine, both get reduced. So just clarify at the side is Br2 gets reduced. Therefore, it is the oxidizing agent, because that's what happens to the oxidizing agent. It gets reduced. Okay, you write a similar sentence for the second one. Pause the video, do that now. Okay, so in this case, Cl2 gets reduced. And the thing that gets reduced, therefore, it's the oxidizing agent. Okay, all right, we're getting easy enough marks up to now. All right, the next thing is for the next 6 marks, it says, hence or otherwise balance the second equation. Okay, so we're only dealing with the second equation. Now we can forget the first one. So underneath here, we're going to balance the second equation. Now what I'm going to do is I'm going to sort of tidy it up a little bit. I'm getting rid of all these oxidation numbers up top. And the first thing we want to do if we want to balance a redox equation, well, do you know what? I'm just going to tell you, if you know what to do, if you're confident, go ahead, pause the video and go and balance this using redox, using oxidation numbers. All right, if you weren't sure where to go and you're waiting for a little hint or a bit of help, the first thing you want to do is write down what's happened in terms of electron transfers. So I would begin by saying Cl2 has, or just actually Cl, has gained 1 electron to become Cl minus. All right, you do a similar sentence for what else has happened here. Okay, so what we should have done is we should have said S has lost 2 electrons to become S plus 6, if you like. So we say S in +4 state has lost to become S plus 6. Okay, so you can see what's happening there. All right, the next thing we've got to do is we've got to balance the electron transfer. So we think about the ratio. In what ratio do we need these two things to be in? One of these is given electrons, one of them is taken. Which one do we need, or what's the ratio of S to Cl? Okay, so I'm writing it down over here, by the way. I'm writing it down here. This is what you should do. Okay, so pause the video, write down the ratio that these need to exist in. Okay, so hopefully you can see that for every one S, it can give 2 electrons. So it can provide electrons for 2 Cls. So it's a 2:1 ratio here. So this 1s can satisfy, if you like, 2 chlorines. Okay, so you've got to basically it's hard to use words to describe it. You have to find a ratio that they need to exist in. So one of these can give electrons to 2 of these. So to balance that, we've got to take this. The chlorine is going to has to be a 2, and the S plus 4 has to be a 1. So let's go to our original equation. I'm going to go, okay, here we're going to have, here we're going to have, okay, we've already got 2 Cls. Okay, so we need 2 Cls, but if you look here, we've actually already got 2 Cls in this original equation. So there's already 2 of these. There's already 2 chlorines here that are both gaining an electron. So see this Cl. This is already Cl2. So each of these Cls, we said, was going to gain 1 electron, and there are 2 of them. So we don't actually need to do anything to this because it's already a Cl2. So it might actually be better. No, it wouldn't. So forget about that. I think we're okay to just say then that there has to be 2 Cls, and there's already 2. So we're going to leave that the way it is for every one of these. So one sulfur is providing 2 electrons, if you like. There's the first one, and there's the second one, and the 2 each. So the ratio here is the Cl2 is to 1s, like that. Okay, so then what we got to do is we've got to balance the rest of this equation here. Balance the rest of it. Okay, so let's have a look at the other atoms in the equation and see what change. So let's check the chlorines. So here we've got 2 chlorines on the left. There's only 1 on the right. So this here is going to become a 2Cl, like that, 2Cl minus. Now the chlorines are balanced. Let's check the sulfurs. There's 1s here and there's 1s here. So that's good so far. The oxygens, there are 4 oxygens on the left here. Here's the 4 of them, and there is 1 and 3 oxygens on the left. So that's 4 on the right, 4 on the left. That's good so far. And then we have 2 hydrogens. Sorry, we have 2 hydrogens on the left here, 2 of them here, and we've only got 1 on the right, just here. So to balance that, we're going to put the 2 here. Okay, so Cl2 plus SO3 plus H2O give you 2Cl minus, SO4 minus, and 2H pluses. All right, guys, so that is that balanced. Now, let's go and check the part 3 of this. It says, why does the oxidizing ability of the halogens decrease down the group? Okay, so this is part 3. So let's label it that. So part 1, 2, 3, and it's why does oxidizing ability decrease down group 7. Okay, so remember what happens when something is an oxidizing agent is it itself has to be reduced. It has to gain an electron. So all of the group 7 elements, fluorine, chlorine, bromine, iodine, are all going to gain electrons. But it's saying that they lose their ability, or the ability to gain electrons decreases as you go down a group. Now, why would this be? So think about if you put fluorine with, say, a metal like sodium. Here's sodium's electron, and we know that sodium's electron is going to go to the fluorine. Here's chlorine with the sodium, and we know that sodium's electron is going to be taken by the chlorine. That's what's happening over here when these things get reduced. So why, when we go down the group from fluorine down towards iodine, does that become less likely? Or do the atoms lose their ability? They're not as good at that. So pause the video and write down an answer to that. Now, what are the reasons for that? Okay, so what happens when you go down a group here then is, first of all, the atoms get bigger. So the atoms get bigger. This puts the nucleus, which is where the positive charge is, further away from this neighboring electron that wants to be taken. So the smallest atom at the top is better at taking the electrons because its positive nucleus can get closer to the electrons. So that's the first thing. The atomic radius decreases down the group. Sorry, increases down the group. Increases, gets bigger. Another thing that happens is the screening effect gets bigger. More shells added means that the pull of this nucleus of this atom is less on the neighboring electron. Screening effect increases. Another thing that you could say is the electronegativity decreases. And electronegativity decreases because of these first 2 points. If the electronegativity decreases, it's got less affinity for that neighboring electron. Now, you could have said any of those things and they would get you the marks, any of these 3 bullet points. You don't need to have all of them because it's just worth 3 marks. Just saying, give a reason. So these are the reasons. The atomic radius gets bigger, which puts the nucleus of that atom further away from the neighboring electron that it wants to take. It's going to be more difficult for it to interact with that neighboring electron. There's also a bigger screening effect as you go down the group. And also when you go down the group, the electronegativity decreases. So quite a challenging question. It looked quite easy on first glance, but it was reasonably challenging, especially in the balance in the equation where you had the chlorine with the ratio 2 to 1, but the chlorine was already in a molecule of chlorine. There was already 2 atoms taking electrons there. So that was maybe a little bit tricky there. But yeah, that's it, guys. I'll leave you with the official marking scheme so you can have a look through it yourself. And that's it, guys. I'll see you in the next video.